Hello and welcome to the first part of this series where I demonstrate how to talk to a Raspberry Pi and Pico W using Bluetooth. In this video I will show you a simple demo that was inspired by fellow YouTuber Kevin McAleer, who is right here. If you want to check out this video, I'll link it in the description. Let's begin. Let's begin. First, we need to install Bleak on the Raspberry Pi. Bleak is a Python library that allows a Bluetooth-capable device to talk to other Bluetooth devices using Bluetooth LE or low energy. Here's a GitHub link you want to explore further. So, you can clone it now. It's easy to install, just install with pip install Bleak. To access the Pi, I decided to use Pi Connect instead of SSH. Here is the session I created for Norman, which is the name of my Pi 4. I already ran some initial tests and it works just fine. All you need to do is create an account and you should be able to sign in your Pi. You can check the documentation on the raspberrypi.org website for more information. Now, first we create a virtual environment as Raspberry Pi OS Bookworm now requires that. And I've already done here, and I called it Blue. So, first you create the environment. So if we look at history, so history grep env, you can see that I created one called, here's a sample one I created, for example. So in this case, I created a library called OpenENV, and you can see I use the VNV command, but I used system side packages. So you can name it whatever you want, but in this case I named it Blue. And then you just activate it with this command. So the reason I did system side packages is because my packages system side have GPIO 0 and PyGPIO, which I used for my tests and my demo. After this, we are ready to go. On the Pico, we just need to make sure we have the latest version of MicroPython, which I do have here. I have the version 1.24.1, but of course, if I was to update it, I would get the new version. There are many ways to do this, such as mounting the Pico as a mass storage device, and then copying the UF2 file. However, I decided to use Thonny to install MicroPython, which you can do right here. So, in this case, I'm going to show you something. I'm going to go into fritzing, and I'm going to show you my fritzing diagram that I ran, that I'm going to show you. So we'll go to part 1 here. So I figured we do this in real time just to show you. And here is the wiring. So the only thing I have wired in is an LED, which here you can use the breadboard. I use this as an example. This is connected to ground. This is connected to pin 17 right here. And the Pico is not connected to anything at the moment. Now you can use the breadboard or do what I did, was just use a panel mount LED, which I decided to do, because it's a lot easier. So, once everything is set up, we're ready to start with the tutorial. So, let's get started. Alright folks, let's get started. So we'll start with the Pico side first, just to get an idea. Now, let's go to BLE sample first, because actually I'm going to save this for later. Now here, I'm going to open it for you guys. We have our libraries. AIO BLE, Bluetooth, async IO. Here we establish our BLE, which we use Bluetooth, and then we set it active to true, and then of course we get our MAC address, and then we print the MAC address for the device, and then we set up our UUIDs, and then we have our IAM, which is peripheral. We have hello from IAM as our message. We have our parameters here, which are important, and we have our functions here, we have message count as 0. You don't need this, but if you do plan to have a count, you need to define the variable first. Here we have decode message, and we have our async functions, because these will run at similar times. So this will prevent the CPU from being tied to multiple tasks. So in this case, we have our send data task, and in this case, we have a global message count. Our message will be our message, and then message count will increment by 1 our message count. And of course, I'm going to get rid of this because we don't need this at the moment. Then we'll do our try except, where we have our message, we write the characteristic, and then we let it sleep for 1 second. You can change this if you want. Then we have our except, where if it doesn't detect, it'll simply say error while sending data, and then it'll continue. Then we have our peripheral mode, where it sets up everything. So we set up the Bluetooth service, our characteristic to write to, our read characteristic, but we're not going to read anything, we're going to write. I will cover this in another video. We will register the BLE service, and then of course we'll simply print that it's starting to advertise, and then we have our while true loop, where it will wait for the connection, and then we'll have the tasks. In this case, we're going to have only send data task. We'll await, because you'll need to do this, and then when we're done, it'll simply say disconnected, and then it'll break, and then we run at our peripheral function. So again, I thank Kevin McAleer for this. If you'd like to check out his tutorial, link in the description, and in the video he also links his GitHub as well, so if you want to check out that code, you can. And that's where I got that code from, so thanks to Kevin McAleer again for inspiring me. So let's move on to the code on the Pi, and we're only going to use this one for now. So here we define our libraries. Yes, we import LED, you'll see what I mean. We have connected false, and you'll see what I mean about that. Our LED is at pin 17. We have this Pico address. Please change this if you are using something else. We have our service UUIDs, and they must be exactly the same as what we got with the Pico so that they can talk to each other. We have our async function, which is called receive data task, because we are receiving data, not sending. But if we were sending, we'll cover that in another video. So we have a response, which will get the characters. We print central received, so it's basically it receives. This will be the central, which is the Pi, and it's receiving from the peripheral, which is the Pico. And if it can't send any data, it'll simply set error receiving data. I created this new function called blink task, where if it's connected, the LED will turn on and off. Simply it will toggle, and it will blink for 1000 milliseconds, otherwise it'll do 250 milliseconds, and it'll wait, and simply it will divide that by 1000. And then we have our connect and communicate, where we'll set up our client. I did this because I wanted to I made some slight changes here, and we only need 2 tasks this time, because we have receive data task and blink task. Well, actually, we need 2 because we need blink and receive, so that these 2 can run at the same time thanks to async IO. And then of course we set connected to false once it stops being connected, and then we get the event loop, and then we run until complete our main communicate and our connect and communicate with Pico address. And that's it. That's all you need to do. You don't need to add the LED I have here, but I will make it available on GitHub regardless. You should still have it, because that way when you connect to the Pico, at least you'll know, hey, the Pico is now connected to the Pi. So let's exit from here, because we're going to run this from the terminal. Okay, so first, let me actually get this out of the way. So what we're going to do is we're going to get this code. We're going to actually have to run BLE sample first. So we'll press this button here, and it's waiting to advertise. So I'm going to run this here. So let's do Python 3 Pi receive. and it's now going to connect. It is now connected. And I know you can't see it from here, but the LED is blinking every second. And you can see that it says hello from peripheral, and here it says it's already connected, and it prints out the MAC address of my Pi 4. So let me exit out of this. Now we have a successful run, so we'll stop. So okay, that was fun. I mean, okay, so we printed hello from peripheral. Big deal. What else can we do with this? Well, I have another code here. It's pretty much the same, except I imported time. And as you can see from the test, I actually did it already here, but I'll show you. It's the same code. The only difference is I added a message called today, which is equal to time.local time, which will give me the time. So let's say you wanted to print the local time of, at least of today. So all you need to do is go here and change from message to today. That's it. You don't need to do anything else. So I'm going to run this now. So I'm going to rerun this. Okay, so it should run. And you can see we have the date and the seconds. So it's pretty cool. So this can be used, for example, to display the local time. So it says here it is June 17th, 2025. So that's pretty cool that we can read the time from the Pico. So let me exit out of this. So you get the idea. We were able to read both messages from the Pico as well as read the time from the Pico. So I declare this demo a success. Thank you for watching the first part of this series. However, we are far from done. All the code will be available on GitHub. Special thanks to Kevin McAleer for his stream and inspiring me to pursue this series. I will link his stream in the description. Stay tuned for future updates, and I will see you next time. Take care.